Hey everyone, this is Alexander from Long Now. I'm going to be hosting the talk tonight, and we'll be getting started in about 1 minute as people filter in. So hang tight. It's great to see we have some kids in the audience. And just so you know, if you have questions at the end, we're going to be taking questions through the chat interface. If they're kid questions, put the age of the kid on there so that we know that they're kids' questions. We kind of want to prioritize some of those. So let us know. All right, well, it looks like we have critical mass, so I'm going to get us started. As I said, I'm Alexander Rose. I'm the executive director at the Long Now Foundation, and this is one of the series of the battery talks that we help facilitate. And Ed gave a talk for our series a while ago, but he has some great updated information on both mapping the solar system as well as asteroids in general. This is an ongoing topic for us, and so the Long Now Foundation was founded as an institution to really think about long-term issues. And I think, we're standing in the middle of probably one of the greatest moments in the last century, where we know that we have these kind of completely 100% predicted events that are going to happen. We just don't know when they're going to happen. And a pandemic is one of them, and asteroid impact is also another one. And they're transcendent effects for the world. And no matter how many times people talk about them coming, it's not until they're really upon us that we take them as seriously as we should. And really, that's kind of the goal of Long Now, is to get people to take these seriously before they become, a catastrophic level threat for the world. And the B612 Foundation, we've been talking to since very early on. One of the co-founders of the foundation was Rusty Schweickart, an Apollo era astronaut, and he gave a talk when B612 was just getting started. And for those of you who don't know, B612 is a reference to the little planet that the Little Prince was on, which is a little asteroid, so aptly named for this foundation. But we've been tracking on this idea of these kind of existential issues for humanity for a while, and this is one where, really I always have thought about the idea that when humanity started a space program, it's almost it's kind of insane that the first thing we didn't do was start an asteroid tracking program. That almost everything else that we do is kind of rearranging the furniture on the Titanic as it's going down. When we know 100% that we're going to have a catastrophic level event that could be even existential level catastrophic, and that we haven't really dealt with that. We dealt with doing other projects, but it's amazing that B612 Foundation has taken this seriously and has been taking it more and more seriously and integrating it into various government programs as well as their own privately funded programs. So I find it one of the most important efforts that's going on around the world. And so I really am excited to have astronaut Ed Lu here tonight to talk about the way this program has evolved and how we might understand it as a civilization, because it's going to be something that we have to deal with literally over centuries. But he also has some information that's coming about much sooner than that we can all engage with, and really how we understand how some of the, we often see these reports in the news about how that an asteroid may be coming close to us, and that I think we have a bad understanding of what those real risks are, and it's one of the main things that B612 is really trying to understand, and how to message that to the world. And so please do pay attention to this, and then also you're welcome to give questions in the chat, and I'll be filtering those through to Ed. And I should also say that Ed recently had a knee surgery, so he's going to have to adjust about every 15 minutes or so. So if you see him, or if you hear his voice change and just having to get up from his desk for a minute, that'll be that. But I think that the presentation will continue on the way. So welcome, Ed Lu. Thank you so much for joining us tonight, and I'll hand it over to you.
Thank you very much, Xander, and Thank you to the battery for allowing me to tell you about the work that we're working on. I'm going to let you guys in on some secrets, I guess, and tell you a bit. You can amaze your friends with some of the things that are going on. You're going to get some insider things on what's happening. So, as Xander mentioned, asteroids are what we're all about, and they do hit the Earth at times. But what I actually want to talk about is the bigger picture. Believe it or not, there is a bigger picture. And I want to talk about the protecting the Earth from being hit by asteroids in context of human development of space, and in particular, the context of mapping and this whole concept of mapping, which is, I think, what we're really all about. So I wanted to start with this first picture, which, if I get my screen to, there it is. Photograph I took from the space station on my last flight. For those who are astute, you might recognize the Great Lakes. You can see off in the distance Ontario and Erie, and down the lower part, you can see Michigan. And what I've circled in white here is a particularly interesting spot, which I used to fly over all the time and used to get me thinking all the time. It's a town called Sudbury, Ontario. And it is interesting for a couple of reasons. Number one, it is the site of an ancient asteroid impact on Earth. A very large asteroid, comparable in size to the one that killed off the dinosaurs. This was about 60 million years prior to that, so about 100 million years ago, landed there. And number two, it has played an important role in the economy of the world, in human evolution, if you'd like, because when that asteroid landed here, it deposited some of the richest iron and nickel deposits anywhere on Earth, because that asteroid was made of mostly iron and nickel. And human beings discovered this and began mining it. And in fact, a company called INCO was formed there to develop and mine these iron and nickel. And in fact, in the early part of last century, was one of the original Dow 30 companies. So it was financially important for the development of industry in North America. So don't let anyone ever tell you that asteroids don't affect daily life, because they do. Here's one where it definitely affected daily life for some people. This was 2013 in the Russian city of Chelyabinsk, and what you're seeing is an asteroid, a very small one in this case, only 19 meters across, so the size of a small building, hitting the Earth at moving approximately 15 kilometers per second, so about Mach 50. It was going over the top of this city of Chelyabinsk. Luckily for those million residents of Chelyabinsk, it didn't actually hit the city. It went over the top of it and then exploded in the atmosphere above and moving away from the city. It had an explosive energy of about 30 times the bomb dropped over Hiroshima. So about 500 kilotons of TNT. So had that hit the city, we would probably have been looking at about 1 million casualties. These people were very lucky. As it was, it collapsed a number of buildings, broke every window, every piece of glass in the city, put about 1,500 people in the hospital. But the actual explosion was about 50 kilometers from the city, thankfully. Now, the important thing to note about this is that this particular asteroid, when it hit the Earth, the warning time was 0. The first that anybody knew about it was when Twitter reports started coming in about a large fireball and explosion over this city. And that was not surprising, because of asteroids this size that orbit the sun, we have tracked well under 1% of them. So 99% of them we know are out there, but we don't actually have tracking information on them. And that means we don't, if one's going to hit, one of those 99% is going to hit, it arrives unannounced like this. So keep that in mind. Most of the asteroids are untracked. So now let me switch topic a bit and talk about the opening of new frontiers. It turns out, I'm going to make the argument that new frontiers, one of the most important things you can do, or that human beings have historically done to enable the opening of new frontiers, is they've mapped them. Okay, and that's why the great powers, for instance, during the great ages of exploration, in the 1500s and so on, they spent such enormous treasure and effort with sending expeditions around the world to map them. And you can sort of summarize the reasons that human beings have wanted to map these new frontiers with the shorthand notation of fear, greed, and curiosity. It's kind of a crass way of saying it, but let me explain what I mean by that. Fear, greed, and curiosity. It's just an easy way to remember it. That's why human beings map new frontiers. Fear, which is essentially defense. It's a code word for defending things. In greed, which is a code word for making money or developing things. And curiosity for science, just to see what's out there. So let's talk about those in a little more detail. I'll give you a specific example here. Remember, I mentioned that the great powers spent a lot of their effort and money on mapping because they knew the importance of mapping. This is actually a very, very influential map with a very long and checkered history. This map was produced somewhere around 15 years after Columbus. So around 1508, I believe, they think it was completed. It's called the Cantino Planisphere. And you see, it's actually quite accurate. But it was one of the very first maps to show the oceans sort of anatomically correctly like this. And remember, this is, less than 2 decades after Columbus. It's really quite amazing. There's a lot of intrigue surrounding this. At the time, the Dutch, the Spanish, the Portuguese, the British were sending expeditions around the world trying to map things out. This map was repeatedly stolen, sort of back and forth, and then disappeared for some hundreds of years, when it was later found on the wall of a butcher shop in Modena, Italy. Really, nobody knows how it got there. Now it's in a museum. But the map is sort of a testament to the importance that the great powers at the time placed upon mapping. And again, why? Fear, greed, and curiosity. So let's talk about that. Well, the fear aspect for these guys, at least, was a lot of it was their competition with the other powers. So remember that they were looking for points of defense, right? Where they were looking for trade routes. There's your greed part. And they just also wanted to be the first ones to figure out where things are for the glory of their empire. Let's move forward to another great frontier. This was the western part of the United States, right after the purchase of the Louisiana Purchase by the United States. And the very first thing that President Jefferson did was he sent out the Corps of Discovery, it's Lewis and Clark, on an expedition to map this brand new frontier with the stated objective of finding points of defense, navigable trade routes, and examples of the flora and fauna that they were to bring back. And this is a map that was produced by Lewis and Clark. And this is what the United States, this is how we opened up the great frontier. Let's fast forward a bit to the 1990s, and it's a different kind of frontier, but a frontier nonetheless. And this is a frontier of genomics, and where we were beginning to understand the importance of DNA and DNA sequencing to all sorts of things. And the very first thing we did was we mapped the human genome. Why? Because we needed to know the relations, the physical relations between the various genes. And 2 projects in particular, one a government-funded project by the National Institutes of Health, and another by a private entrepreneur, scientist named Craig Venter, did primarily most of this mapping. And the reasons were also the same. Fear. Well, it was defense against diseases, many of which are genetically caused. greed. Well, obviously there is a fortune to be made if you can figure out how to cure some of these diseases. And curiosity. If you'd like, the code of what we human beings are is written in our DNA. And so the mapping of the human genome has turned out to be an incredibly strategically important project. And much of the genetic medicines and things like that that are becoming online today are a direct result of this mapping. So my argument is that the frontiers, the development of frontiers, is something that is enabled by mapping, and that we should be thinking about what should we be mapping to open the next great frontier. And here's where it gets exciting, though, because there is sort of a sea change happening here. I'm going to argue that the next great frontier is space, and I'm going to try and back this up with some numbers here. If you look at the economy of space, and you can loosely define that as if space was a country, what would be its gross domestic product? And it turns out that the major investment banks, your Morgan Stanleys and Goldman Sachs's and so on, have been studying this question for quite some time. And they've actually, they all have their numbers on how big the space economy is, and they all roughly agree. This is about 2 years old. The latest number I've seen is it's about $500 billion now. Which would put the space economy not particularly large if it was considered its own country, but the key is it's growing fast. It's all about the growth rate. So on the right side of this graph, I'm showing the number of spacecraft launched from Earth by human beings, broken down by whether or not, the country that they're from, Russian or American, military or non-military, and so on. But you see something interesting sort of happens around 2012. And in fact, if you were to continue this through the numbers through 2018 and 19, it goes through the top of the graph. It's way off the top. It's well over 1,000. And 2020 is probably going to be 1,500 or so. So something very, very interesting is happening here. In fact, if you look at the growth, it's all in the green section, private. In fact, private launches of spacecraft now utterly dominate over government launched spacecraft. More than, I think some probably around 80 to 90% it will be this year. What's happening here? Well, this is sort of similar to the internet revolution or the PC revolution even before that, in that what's happened is that the price and the accessibility of being able to build a spacecraft has dropped to the point where small startups can go do this. Small groups of people, student-led groups at universities can launch spacecraft. 5 smart graduates from a university can say, we're going to start a company and we're going to launch spacecraft. And next thing you know, they built this company called Skybox, which they sold to Google, which now has been sold to a company called Planet Labs, which was another group of essentially a startup. And that wasn't possible in 2000 or 2005, but it is possible now, and it's grown so rapidly that it's completely taken over the in terms of numbers of spacecraft launched. So let's look a little bit deeper here, and if you look at the growth rate of the economy, like I said, these major investment banks have been following this for well over 10 years. If you consider space as an economy, the growth rate of space is about 8 to 10% per year faster than the growth of the terrestrial economy, the economies on, of Earth, if you'd like. And 8 to 10% per year difference doesn't sound like a lot until you consider the fact that the most important or the most powerful force in the universe is compound interest, right? Anybody here who has ever been to China, say in the 1990s, and compared it to now, can see the difference that 8 to 10% difference in growth rate makes over a couple of decades. It's incredible. Okay, that is roughly the difference in growth rate between China and the United States. And if you have an 8 to 10% difference in growth rate, and you do that for 2 to 3 decades, you go from an economy which was largely agrarian and where everyone was riding bicycles to what you have today. And that is, in fact, the difference in growth rate between the space economy and the economy on Earth. So what will happen in 2 or 3 decades at this kind of growth rate? Now, it's always dangerous to predict, you know, they say it's always dangerous to make predictions, especially about the future. So will that difference hold? Don't know. But if it does, then the space economy will actually become, you know, one of the major economies. You know, we'll pass some of the currently larger countries, and by the end of the century, we'll actually dominate over the terrestrial economy. That's an interesting thing, isn't it? So when people talk about the opening of space, we're not talking 1,000 years. We're talking 50 or 100 years at these kind of differences in growth rates. And that means that for the kids out there, you should be thinking along the lines that the space economy may even be dominant by the time they're adults. That's an interesting thing. So space affects your everyday life. Maybe not like this, but this is just a comic that I like. And I will show another photograph that I like, which is Elon Musk's car. This is actually a photograph of it on its way out towards the asteroid belt. I do believe that SpaceX has played a large role in this. It will turn out to be one of the most important companies in human history because of what they have done to bring down the cost of launching things into space. So what does that mean? I think that means that mapping of space is going to be incredibly, incredibly important. Strategically important, economically important, scientifically important. And that those who realize this now are going to be at great advantage to those who do not realize this. As they say, you know, change happens, you know, slowly, 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 and then all at once, right? And that's only true to people who aren't paying attention. So what do I mean by mapping space? Remember, I mentioned that most of the asteroids, 99% plus of the asteroids, are uncharted. Well, almost everything in the solar system that's a terrestrial body, almost all the worlds in our solar system are asteroids, as it turns out. There are millions of them. There's 8 planets, 9 if depending upon how you want to count it, but there are millions of asteroids. So the vast majority of the bodies of land, if you'd like, in our solar system are asteroids, and most of those are uncharted. So let's look at that. Well, I've got a little map of the solar system here, but it's a moving map, because that's the interesting thing about the solar system, is that everything is moving. So what I've got here is the sun in the middle, Mercury, Venus, Earth, Mars out here, and hopefully this thing will play. There we go. These are all the known asteroids, which, remember, represents about 1% of the actual number of asteroids. This is the asteroid belt right here. This is the Earth's orbit, and these are what are called near-Earth asteroids. But the important thing to note is that the Earth, the planets, and all the asteroids are continually moving. So if I talk about building a map of the solar system, what I'm actually talking about is a moving map where everything is moving. It's not just where something is, but where it's going and where it's going to be in the future. That's the important thing. So how do we generate that? Okay, and why is that going to be important? So let's delve into some specifics. Well, if I knew where all these objects were, then I can do some tremendous science. I can tell you about the origin of the Earth and the origin of the solar system and where we came from, because the origin of the Earth is written in the orbits of all of the bodies of the solar system. So if I knew the orbits of all these objects, I can tell you how the universe, or excuse me, how the solar system evolved. So that's the first powerful thing I can do if I have a map of all the asteroids and where they're going. If I have such a thing, I can also send probes, scientific probes. Here's an example of a neat picture. This was taken about a year ago. This shows the surface of an asteroid, and if you look down to the left, that's the shadow of a spacecraft which is dipping down to go pick up a rock sample. This this scientific probe, it's a Japanese one, is on its way back towards Earth, and actually is going to parachute this container with one of these rocks somewhere in this picture is going to be parachuted back down to landing on Earth in December. Very neat. But you can only go visit an asteroid if you know where it is. So what's the next powerful thing you can do if you have a map of the solar system? Well, you can enable commerce. So again, shorthand notation greed, but why is that important? Well, remember that Earth is fundamentally limited in the amount of energy and the amount of resources that we have. The Earth cannot continue to grow. Human society cannot continue to grow at an exponentially increasing rate. Exponential is the key part here. We can grow, but you can't continue to do that for more than a few hundred years at our current growth rates. And that's because you run out of energy and raw materials. But the energy available in the solar system, primarily solar energy, and the amount of resources available is millions of times larger out there in the solar system. This was first realized by a guy named Gerard O'Neill, who's a professor at Princeton, and he wrote a number of influential books, including The High Frontier, where he first brought this idea up in the 1960s. One of his students was a guy named Jeff Bezos, who later went on to found Amazon. And Jeff Bezos likes to say that in the future, he believes the Earth will be zoned light industrial and that the heavy manufacturing will be done elsewhere in the solar system. When is that going to happen? Well, if the current growth rates of the space economy continue, then it will not be more than 100 years. It may even be 20, 30, 40, 50 years from now. But that will eventually have to happen. How is that going to happen? I haven't the faintest idea, meaning the specifics, which company is going to win, who's going to do what. But they're going to have to do things like this, which is a resource map of the Permian Basin in Texas for natural gas. Maps are the basis on which companies have historically been able to lay claims to natural resources, which they then invest money into getting them out of the ground. Okay, and it's enormous sums of money have to be raised in order to pull resources out of the ground. So there has to be a way in which someone can lay a claim to it. Otherwise, it's not a good investment. And so one of the real things that allowed the development of the American West is, in fact, this idea of land claims. I think a similar thing is going to happen in space, and it'll be based upon some sort of map of where things are. So where are the resources? Well, you tell me where the asteroids are, and I'll tell you where the resources are. In particular, the thing that's likely to be extremely important is water. Water being made of hydrogen and oxygen, also known as rocket fuel. And I suspect that one of the most important resources that human beings will take advantage of is water. And water turns out to be something that's very prevalent on a lot of asteroids. Let's go back to our discussion about protecting planet Earth. Remember, I mentioned that, asteroids, they sometimes hit the Earth. I showed you the one in 2013. Here's an explosion that happened in 1908. Now, this one's been 100 years. On June 30th in Tunguska, Siberia, known as the Tunguska event. It was an asteroid probably around 45 meters in size, so size of a large building. But it took out an area roughly the size. What we've done here is we've shown you a number of large cities where we transposed the area of destruction, which was about 2,000 square kilometers. You could see that it would be enough to completely obliterate New York or San Francisco or so on. And those sorts of things hit the Earth every couple hundred years, but and it's been, and the last big one was in 1908. Interesting side note, June 30th is now commemorated as Asteroid Day, for exactly that reason, that June 30th is the anniversary of the Tunguska explosion. It turns out that we can actually prevent an asteroid from hitting the Earth. It's almost trivial to prevent an asteroid from hitting the Earth if you know that it's going to hit. Okay. If you know years in advance that something's going to hit us, you only need to change the speed of an asteroid by a part in a million, which is, incredibly small. The easiest way to do such a thing is to simply run into it with a small spacecraft. It's called a kinetic impactor, and the idea has been used before for scientific purposes, but never to really deflect an asteroid yet until next year. Because the first test mission of deflecting an asteroid that's not going to hit the Earth is called the DART mission, and you can follow that. It launches in October of next year, and will deflect a small asteroid on purpose. Okay, so again, we have the technology to keep an asteroid from hitting the Earth. You run into it with a little spacecraft, but you can't protect against an asteroid that you don't know is going to hit the Earth. How do you know if an asteroid is going to hit the Earth? You need a map. Where are all the asteroids and where are they going? If I know that, then I can tell you which ones we need to look out for and which ones we may need to deflect. So this map is going to be incredibly, incredibly useful. And I'll let you in on a little secret here. It's going to be useful sooner than you might think. And here I'm talking about a year and a half from now, when it's going to be very, very interesting. But first, let me get to how do you go about building a space map? Well, what you have to do is you have to have telescopes. You have to have telescopes, and what you do is you measure the position of an asteroid by spotting it in the sky, and then you spot it again at some later time, maybe the next day, maybe a few hours later, you spot it again, and over a period of months or years, if you can continue to track that asteroid, you can calculate its orbit. This is a procedure known as orbital fitting, and it relies upon the fact that we understand extraordinarily well the laws of celestial mechanics. Isaac Newton first came up with these. They were refined and corrected by Albert Einstein. And using modern day computers, we can actually add in many, many small effects that we understand quite well, like the gravity of other planets, other asteroids, the fact that the sun isn't quite a sphere, it's actually sort of oblate because it's rotating, and many other small effects. So the tracking of asteroids is really a matter of spotting them with telescopes and huge computation, okay? So a couple things have changed in the most recent years. On the upper left, I'm showing the telescope that is currently tracking, discovers more asteroids than any other telescope on Earth. It's called the Pan-STARRS telescope. And it accounts for about 500 or 600 asteroid discoveries per year, which is awesome. Remember, though, I said that there's about 1 million asteroids still to be discovered and tracked. So 500 or 600 a year doesn't get you there. In the middle is a telescope being built in Chile, funded by the National Science Foundation. It's under construction right now. You can see the dome being put up. This picture is about a year old. This telescope, and here's where things are going to become interesting, is going to be about 10 times more powerful at tracking asteroids than all other telescopes combined. So it alone is going to increase the rate of discovery of asteroids by more than tenfold when it turns on, which is in about 18 months. And I'll explain why that's critically, what's so interesting about that, and why we need to get moving on the next aspect of it, which is the calculation of the orbits of these asteroids. Now, these calculations are not trivial and they're not small. They are, however, something that we understand very, very well. For instance, when NASA sends a probe to to Jupiter or Saturn or something like that, we can actually target things extraordinarily well because we understand these laws. All right, but there's a big difference between discovering 600,000 asteroids and calculating all of those trajectories versus that one spacecraft that we're doing, that we're going to, and this difference in scale is something that can be attacked via cloud computing. This is something that's new. And so the tools for building a space map are now coming into place here. This telescope, which will be called the Vera Rubin Observatory, it's going to get us the data. We now have the capability to turn those observations into orbits via use of enormous cloud computing capabilities, which are now actually quite inexpensive. This is going to change everything. In the bottom right, I'm showing that there's actually hundreds of thousands of asteroids that even the Vera Rubin Observatory will not be able to see. And we're working on some ways which we believe will actually be able to go another factor 10 beyond what the Vera Rubin telescope can be. So I think in the next 10 years, we're going to get to the point where we will be able to get the data on tracking these asteroids. And we will be able to turn this into a map, a highly accurate map of the solar system we live in. So what's that mean? That means, a predictive model. Where are those asteroids? This is kind of what it looks like. This is, where are those asteroids going to be in the future? Okay, it's not just where they are now. So the little blue lines are showing actual asteroid orbits. And what you need to understand is how you navigate between them, how you understand where they're going to be in the future, and what the uncertainties are in each of those orbits, because whether or not one of those things is going to hit the Earth depends upon how accurately you can tell me that orbit. So this is what our foundation is building. A project of the B612 Foundation called the Asteroid Institute. Our primary goal is to build this 4-dimensional map of the solar system. Why do I say 4 dimensions? Because there are 3 spatial dimensions plus time. And this is our major project, which we believe is going to be extraordinarily valuable. I believe that the vast majority of scientists don't appreciate the importance of it yet. The vast majority of the public doesn't appreciate it yet. But when it becomes extremely important, they're all going to be thankful that we've done this. So let's get back to a little bit to the Vera Rubin Observatory. When it turns on, it's going to begin tracking a lot of asteroids. And what we do know from the discovery rate that we understand it's going to have, based upon its performance specifications, is that we're going to be discovering, rather than sort of 1,000-ish new asteroids per year, but in the range of 20,000 new asteroids per year. Which means that within about a year or two, the vast majority of asteroids that we know about will have been discovered by this observatory within the last year and a half, which means we will have limited tracking. Remember I said before that the accuracy with which you can determine the orbit of something depends upon how long you have tracked it for. And at that point, most of the asteroids will have only been tracked for a year or two, because the Rubin Observatory will only have been operational for a year or two. So what that means is that there's a considerable uncertainty in many of these, in most of the asteroids at that point. Why is that important? Because when you find ones that are going to be coming near the Earth, and we know that from the statistics of it, that we will be finding hundreds of these things, that those are the asteroids which have a chance of hitting the Earth. So what do you do with information like this asteroid has a chance of hitting the Earth? Or what does it even mean to say this asteroid has a chance of hitting the Earth? Well, folks are pretty familiar, I think, with this idea of hurricane tracking cones, especially anybody who's lived along the Gulf Coast or the Atlantic seaboard. You monitor this every time a hurricane heads your way. You look at the tracking cone. But the tracking cone doesn't tell you exactly where that hurricane is going to go. It gives you a range of possibilities. There's some spreading cone over which that hurricane, all these tracks are consistent with all of our weather models, but which one of them is correct? You don't know. That's why there's an uncertainty. Well, remember that when we have only a year or less of observations of a particular asteroid, there's a whole range of possibilities that are all consistent with those limited number of observations. And which one is correct? You don't know yet. So what that means is you actually get something like a prediction cone for asteroids. So I was thinking the other day about why this is so important. I think the pandemic has really brought out the importance of showing your work and being transparent when you make predictions about things in the future that affect world policy. And an asteroid that has a chance of hitting the Earth is certainly in that category, and we will be having hundreds of those cases starting in 18 months, okay? And I think that when we are presented with the cases like that, it is critical that we show our work. We have to show in an open manner what these possibilities are so that everyone else can check our work, check our assumptions. If they have different assumptions, they can make those and rerun the models, and such that it's not just a matter of us or anybody else or some government agency or whoever telling you this is the way it is. Okay, and I think, you know, we've seen the result of agencies, government agencies that just tell you this is the way it is without explaining their reasoning or showing their work, and that I think we've seen has causes a lot of causes mistrust. And so let me give you an example. About a week ago, CNN put out a big article about an asteroid that might hit the Earth on the day before the election. A truly abysmal piece of reporting, okay, because this asteroid is only 6 feet across. Okay, so if it hits the Earth, it's a meteor in the sky. It has no possibility of hitting the ground. It will just be a light show. And so I think they thought it was cute, perhaps, or perhaps they simply didn't understand it. But what we did was we actually took the observations of these things, and we're going to plot for you what a asteroid prediction cone looks like for that particular asteroid. It turns out it's called 2018 VP1. And what I'm showing here is this is the hurricane, or if you'd like, this is the range of possibilities of that asteroid. As it goes past the Earth, you'll see it'll split up and spread here, because depending upon how close it comes to the Earth's gravity will affect it in different ways. And I think a better image is actually this one, where what I'm going to plot for you is how close do each of those model runs come to the Earth. Remember, every one of these model runs is a possibility. Every one of them is consistent with all of our observations. So what the blue circle there is the Earth, and what I'm showing you is where all those runs hit. So you see the range of possibilities is quite a bit larger than the Earth. Some of those do hit the Earth. In fact, this is how we determine the probability that this asteroid might hit the Earth. This asteroid actually has about a 0.5% chance of hitting the Earth. Not hugely high, not zero either. Again, the point that CNN missed is that even if it does hit the Earth, it's not going to cause any damage. But this is the kind of thing that we're going to be able to produce and put online and allow people to access in an open manner. Our project is an open source project. For all those thousands of asteroids that the Vera Rubin Observatory is going to discover that are much larger, that have a chance of hitting the Earth. And those things become issues of public policy. Where might they hit the Earth? What are the chances? What are our options? And I think the hurricane warning folks have done a tremendous job over the last 10 years at depicting these things and making that information public. And that has allowed people, it takes the fear out of it when you understand this. It takes the fear mongering out of it, to a large extent by showing your work. And so one of our key goals over these next few years, and why we need to work fast, is we need to get the system sort of ready for prime time as these discoveries come in. So, just to back it up, I think that this, in the long term, and when I say long term, I'm talking decades, this space map is going to be extraordinarily important. In the short term, it's actually going to be an important public policy tool, I think, here over the next few years, because we are going to find asteroids that have a chance of hitting the Earth. And we may even find one that is going to hit the Earth. And though that information needs to be disseminated in an open and transparent manner. So this is what we're doing. It's interesting. As I look back on all the things that I've done in my career, I can honestly say I think this is the most important work that I've ever done, and I think I believe that this is going to be of lasting importance to the public. So I do want to say that I want to thank our supporters. Our foundation is entirely supported by donations, so from some very generous people. So I do like to show the folks that have actually allowed us to do this work, and thank them. I think it's important that we thank them. And I would like to say that if there are folks out there who do want to get involved in some way, you can go to our website, b612foundation.org, and reach us there. You can reach out through that website, and we would love to have folks who want to be involved in this. Again, you are, if you understand this, if you get this, you're going to be on the leading edge of something that's going to be very, very important. So with that, I think I'll end my yakking right now and open it up to questions.
Thank you so much, Ed. This is fantastic. And I know, especially with your knee surgery, you did a great job of pushing through here. So if you need to stretch while we move over to questions.
I've been doing it while we've been talking. So.
All right, excellent. Well, thank you so much. And we also have Danica Remy here, the president of the B612 Foundation, and she's going to be answering questions and posting links within the chat window. I think we already have a question about who to contact around discussing internships and other things. So she's already starting to answer some of those questions. So please feel free to answer those, and I'll get some of the questions started while the other ones come in online. Let me pull up my notes, but I think an important thing to think about as we think about problems that are these long-term kind of entirely predictable events, just like we are living through with the pandemic, that there was many people who said that this was happening, and various societies prepared in different ways around them, and even our own, and the United States prepared in multiple iterations around this. And I think we've even seen this even with asteroid impacts, where different administrations effectively have prepared for it in better ways. But then if you happen to get hit by one, you get hit in a time when it hasn't been taken seriously. It's a serious failure of long-term planning that we don't have consistency around this. And I was particularly struck by this when I was in Sudbury, Canada, the place that you mentioned at the beginning of your talk, Ed. So all of the nickel deposits that we use for things like the 10,000-year clock project actually come from Sudbury. So I was there, and one of the first mining engineers that we worked with on the clock project was the lead mining engineer from the Sudbury, Canada project, where I was 5,000 feet underground, looking at these deposits that had hit from effectively a prehistoric meteor impact. And it's just kind of stunning. You're 5,000 feet underground looking at a mineral impact that hit the Earth, and clearly, must have had a massive impact on the Earth at that time, but now has been a effectively an economic resource for over a century.
Hmm.
And it is just it is stunning to be standing there and feeling the very real term impacts, you know, even tens of thousands or hundreds of thousands of years after that impact that is instrumental to our economies today, and kind of not understanding how that works until you're standing in that mine. So I think it really can't be underestimated, and I want to appreciate the work of the B612 Foundation and the Asteroid Day project that Asteroid Day just happened, you know, not that long ago. But the idea of taking these long-term effects very seriously, so that we can plan for them in a useful way. And obviously, you can't divert all your resources to these, but you need to divert some of your resources to these. And I think that's really the message that we see here of how to prioritize things so that when a pandemic or an asteroid hits, or a tsunami, or any of these, you know, that we at least have done the right level of work. And I think in general we don't do the right level of work. So I want to really thank you guys for that work.
But it's also key though that you can also be doing these things from a development perspective, and you can do that. It's all the same thing, in that the solution to all of it is building that map.
Indeed. Yeah. No, I think you correctly pointed out that the maps themselves have economic importance regardless of whether or not things are hitting the Earth, because there's all kinds of other reasons why we might want to do these. And you mentioned the Chelyabinsk and the Tunguska effect, and one of the things that's interesting to me, I mean, I assume that one of the reasons that we now, you know, two of these have hit effectively Russia in the last 100 years is just because of the massive size of Russia. But you know, obviously we have also massive oceans, and I'm wondering if you can talk a little bit about the effects of if those two things could hit the ocean in different ocean basins, what that might have resulted in, because I assume they would have resulted in fairly massive tsunamis. Or I would love to hear your
Well,
take
the
on that.
Chelyabinsk one was unlikely to have created a tsunami because its explosion was very high in the atmosphere. Now, Tunguska could have, where depends upon the size of the tsunami you get. Really depends upon the depth of the ocean in that particular area, and how close you are to the shore, and so on. So it's one of those things where it very much depends. You know, we do know that, you know, something larger than that, you know, 100 meters across, something that would hit the Earth, you know, there's every you know, maybe a 1% chance in our lifetime, will certainly create a tsunami. And there would have a 70% chance of hitting water. You know, that's not a huge risk, you know, 1% chance in your lifetime. So every 10,000 years, such a thing hits the Earth. But the explosive energy of that, you know, if it hits land, is really, really bad. That's more than 100 megatons, which is larger than all the bombs used in World War II. So you don't want that hitting land. You also don't want it hitting water. So, you know, I would say we really don't want such things hitting the Earth. And it's entirely within our capability to prevent that. In fact, that one of the goals of this Vera Rubin Observatory is to catalog the great majority of asteroids that size or larger. So the kind that would be sort of World War level size. Not the smaller ones that would only destroy a city or something like that, but you know, this sort of mid-level size ones. That's what the Vera Rubin Observatory will accomplish.
And I shared in the video chat a piece that we did several years ago to represent. We did it in partnership with the folks at Google to represent how often we actually do get hit by asteroids around the globe, and it's an eye opener. So, you know, when you're all done here, you know, click on it and you can get a good picture of how often we get hit. And yes, the music is from Broken Bells.
Yeah, yeah. What Danica showed is the asteroids that have been larger than a kiloton of energy that have hit the Earth in the between the years of 2002 and 2012, I believe it was 2013 perhaps. So roughly a decade's worth of data. It was unclassified. And so it's real data showing the locations of sort of atomic bomb sized explosions on Earth. And there's a lot of them. I don't know, 20 some odd explosions like that in a decade.
Wow. Yeah. No, I had a similar kind of revelation when I was trying to figure out how to get data back from a very remote site. And one of the ways that you can do that was invented in the 50s was by bouncing information off of the ion trails from micrometeorites that are hitting the Earth all the
That's
time.
right. Yeah.
And it's a proven technology that was developed in the 50s that wasn't really kind of useful until packet transmission data, because the latency is kind of on the order of minutes or hours. But once you realize it, you know, on the micrometeorite scale, there's always things hitting the Earth. You know, for something like a weather station, it's very useful. But yeah, the amount of things hitting the Earth is pretty stunning. I wanted to get a question in from Augustine Bowie, who asked, you know, you guys have a mapping effort, but what other mapping efforts are there going on? Are there other countries and other institutions that are working on?
Yeah, I mean, the folks working on the Vera Rubin Observatory are working with us, but there is, you know, for instance, there's a pretty substantial program at NASA and one at the European Space Agency. Their goals are a little bit different, though. Both of them are working, as we are, to generate accurate predictions of potential impacts. But we're the one that's open source, and we're the one where, you know, a key part of our project is showing our work. And one of the things I think is going to be critical is, you know, they're aimed at producing accurate data for researchers. And we're aimed at not only that, but allowing other researchers or others to see our work. Okay, and so there's a big difference in our level of openness, I think. We had all better agree on when a particular asteroid has a chance of hitting the Earth, and when we get down to the details of what are the chances, you know, this is where it is useful to have multiple models. Okay, you know, for instance, with you know, we saw this with you know, hurricane tracking models. You will see you know, the National Hurricane Center has a different one than there are other models run by other research groups, and it's useful to overlay them, because sometimes there are slight differences, because there are slight differences in assumptions. And but again, when it comes down to having a real threat, which it's quite possible that we're going to have within this data set coming up, I think the transparency part is going to be critical.
Indeed. Yeah, no, I mean, I think I mean, as you pointed out, we've seen when agencies don't use transparency to their data, then it can lead, you know, especially as we've seen with the pandemic, an undermining of the information that they put out. So
I will say that we have about 1/100th of their budget, and yet I think we're doing quite well. I think you one of the advantages, there are many disadvantages of not having enough money, but one of the advantages you have is you get very scrappy. I think we're quite efficient.
Indeed, but I think that, yeah, I
Very
mean,
scrappy.
even yes, very much so. And I do want to put out the point that that it is silly that that efforts like yours have to be as scrappy as they are. So I think that it's worth pointing out that, you know, as we face existential threats, many of which get many orders of magnitude higher funding than you do, that it isn't funded as well as it is. And on that point, I mean, you mentioned an upcoming telescope coming up that is going to improve this by orders of magnitude. Are there other projects coming up that that you can mention that are on a similar trajectory to helping us?
Yeah, well, that's the big one. And again, so we're roughly 18 months from it turning on. There is a proposal for NASA to build a space telescope, very similar to one that we had originally proposed about 10 years ago. It's unclear if that is going to get the funding. Its capabilities will be roughly similar to the Vera Rubin Observatory, but it'll be a nice complement to that. We our ideas on using small telescopes, a large number of small telescopes, using extraordinarily fast onboard data processing. We think that the next generation of asteroid observing things, telescopes, are actually going to be very much cheaper by taking advantage of the fact that satellites are getting cheaper and the fact that computation is getting incredibly cheap. And so we're working on that. We've been running tests. In fact, we ran one this last weekend in a radiation beam line down in Southern California, beginning to test some of the components of that.
Well, it's a huge benefit to have some of those arcs of technology moving in your favor, at least.
Exactly.
For
exactly.
Sure. I think we've covered the questions that were coming in, unless anybody else has some other ones. And Danica, do you have anything that you want to mention before we sign off?
No, there was one question here that I did want to see if Ed would answer. Michael is asking, what's our elevator pitch for this problem?
I would say that our elevator pitch is that mapping of the solar system is going to be incredibly strategically, economically, and scientifically important, because it'll help us develop the space frontier and protect the Earth. And that the date in which this thing is going to become critical is sooner than most anyone imagines. And we're talking under 2 years when this capability is going to be critical.
Well, thank you. And I mean, I think it's a really great point. Whereas, that we had many people predicting the pandemic, but it wasn't until it was upon us that it became critical. And we're going to be standing at a precipice similar to the one that we were in February, at some point with an asteroid. And and you guys are going to be at the forefront of that, and I want to congratulate you for that. Thank you for doing the work when nobody else was paying attention, but especially that that we'll have some of the preparation in place, and I really hope that we'll have vastly more of the preparation in place by that time. So I want to thank you all for joining us tonight. I'm posting a link of Ed's talk from the interval, but I believe there'll be a version of this talk also posted that will also be available. And so I'm posting it now before we. Yeah, so it sounds like the battery will post this version of the talk. We have the one that was from, I don't know, about a year ago, I think, at the interval now, which I'm posting so that you have it.
Pre-pandemic, back in the day.
Pre-pandemic.
Yeah. We could have a cocktail together.
Back when all of these things were very esoteric and just an idea in the sky. But
I also posted a link to our annual report. We're in the process of updating it right now, but it also kind of gives a kind of an overview of all the different research and our work.
Thank you, Danica. And I would say, in general, Asteroid Days now, it's a June event. That's correct? Yes.
Any day could be Asteroid Day.
Yeah, June 30th. June 30th is the recognized day.
Indeed. Yes, but if any of you have institutions or efforts that want to participate, there's no kind of too small or too large ones that have, and all the things that I have joined in for have been just amazing and great, both science and just generally informative events. So thank you guys, and thank you all for joining us here.
Thank you to the Battery for hosting us, and thank you, Xander.
Thank you guys. Take care.